Ethereum operations. For a simple Ether transfer, the amount to transfer and the target address are specified along with fees or gas points. The amount and the fees are transferred to their respective accounts. So think of this as a transaction. So this is A having this address out here. This is B having this address. So A wants to send B some ethers. So what all the parameters he will give? So he will first give his account number, B's account number to whom he wants to send. That means the recipient's account number. Then he'll give the value, how much he want to send in ethers. It can be changed, the units can be changed, it can be way, ether or any unit as such. And this is the gas point, which I'll cover in the next slide. So this is the computational fees basically. So these are the parameters which the sender gives, and then the transaction is occurred. Smart contracts is designed, developed, compiled and deployed on the EVM, that is the Ethereum virtual machine. That can be more than one smart contract in an EVM. So there can be many smart contracts in an EVM. You can deploy them separately, and each node in the network will have some EVM running on them, and they will deploy the same smart contract on their EVMs, and it will work in a network, the whole smart contract. The execution is extracted from payload fields of the transaction state of smart contract may be updated by this execution. Okay, so the execution happening out here is taken from the payload field. Payload field is as in the Coinbase, or you can call it the ether balance out here. So he is having say 40 ethers. So now the payload field is this 40 ethers, and this transaction will take out 20 ethers from it. So now he will be left with only 20 in his wallet, and 20 will be given. So that is what is meant out here. And this is what is like changed when the execution is done. State changes are stored in blockchain. Only the state changes are stored in blockchain, because it is the storage is immutable and it is quite expensive. So only the important things that are supposed to be stored in the blockchain, that are only stored, and all the elementary things are stored in stored as off-chain data, like that. Then Ethereum full nodes, as in a full node or a participant running the Ethereum on his machine hosts the software needed for transaction, initiation, validation, etc. Next, we'll move on to the incentive model. So gas. Firstly, you have to remember what is gas. Gas is a special unit. It is mostly measured in points. So gas is a special unit in Ethereum which is totally different from the ether. Why it is different, I'll tell you right now. Second, it measures the amount of work a set of action takes to perform. So there are many actions going on. So each action is taking some amount of computational work. So by adding all these works, the total computational power needed is converted into gas points. The amount of that computational power is represented as gas points. And gas is directly proportional to the computational resources. So if more computational resources are needed, then the gas amount will be more. And if less computational resources are needed, then the gas price will be less. Every action needs crypto fuel for or gas. Okay, so every action in Ethereum needs a crypto fuel or gas. So why is it measured in gas and why not in ethers? So the main problem is that ether is a unit which can change on daily basis. The value can change on daily basis of the ether, but for this we need a the computational power. For the computational power we need a computational fee which remains somewhat static. So that's why we have given a new unit known as gas. which is not dependent on any kind of uh, change in daily basis, unlike Ether. Transactions are rejected if fees specified and the gas points are not sufficient. So obviously a transaction will be rejected if the fee specified for it or the gas points is not sufficient. So firstly the miner will validate is that much how much the computational power is needed for it. Then he'll check it with the gas. If it is less or insufficient, then the transaction will be rejected. And what about if it is more? So if a transaction is having more um, gas points than what is needed, after the execution of this transaction, all the gas which is left over will be sent back to the sender. So if this is the sender, he'll get all the extra gas points back to him. So these 2 points are only basically for gas in transactions. Now what about gas in blocks? So each block, there is a thing that in Ethereum you can put as many transactions as you want. So what is the thing which stops you from putting all the transactions in a block? That is this gas. So there is a gas limit for each block. So what happens? Every sender puts some gas with his transaction. So there is a limit. So like if you take all the transactions and their sum of gas points, it should be less than the gas limit of this block. If it is more, the block cannot be formed. So in order to do this correctly, all the miners take into consideration that how much gas is the limit, and accordingly they take in the number of transactions needed to accomplish that gas a little less of that. So there we have an example out here. If a block has a gas limit of 15,000 units or 15,000 points, and there are transactions, a lot of transactions are there in the mining pool, and each transaction is say having 300 gas points for this execution. So in a block, he can at the max put 50 number of transactions, as the gas limit, which is 15,000, and the gas per transaction, which is 300, should be divided to get the number of transactions, which is 50. So you can put only 50 number of transactions in a block for this example. If the gas limit is more, you can put more number of transactions. If the gas per transaction is more, this gas limit remaining constant, then the number of transactions will reduce. So it is like this. So this is the whole incentive model in the Ethereum and how miners get paid for their computational work. This whole gas thing goes to the miner who puts it in the block and mines the block. So this is an added reward to the miner. It is basically his computational power which is getting rewarded. Thank you.